Okay, this is a run through of lesson number 6, which is called dividing for roots. The wording in this lesson, the wording in the question says, what are the roots of blank given that blank is a factor? So it's important that you understand that a factor, its main use in this lesson is that it divides in evenly. It divides in evenly. That's the whole point of a factor. That's the usefulness when we're doing division. So that indicates that we should be dividing. So we need to divide, then we need to factor, then we need to find the roots. And then I'll even show you how to graph it. We're going to focus on these two questions, number 8 and number 9. So let's do number 8. The division will be a little bit quicker. You could always slow down the speed on the video if you want, if it's too quick. But we've done division enough by this point. I have plenty of videos up on division already. So let's move through this a little briskly. 3x goes into 3x cubed, x squared times. When you distribute that down, it's going to get you 3x cubed plus 3x squared, parentheses, and subtract. These cross out. 18 minus 3 is going to be 15x squared. And we can bring down the plus 33x. Get rid of these little swoopy lines. 3x goes into 15x squared now. It goes in a positive 5x times. Distribute that over. Gives me 15x squared. Then 5x times 3 is going to be plus 15x. Parentheses and subtract. Cross that out. 33 minus 15 is 18x. Then we bring down the plus 18. Last step. 3x goes into 18x 6 times. So that's plus 6. Distribute that plus 6 over. That's going to be 18x plus 18. Parentheses and subtract. And they both cross out. Give us a 0 remainder. That's what we like to see. In order to find the roots of this equation, the roots of this guy, we're instead going to use its factored form. We don't want to use this big ugly polynomial under here. We want to use its factored form. Its factored form is this times this. So we're going to rewrite it like that. 3x plus 3 x squared plus 5x plus 6. We want to factor it a little bit more. This part right here is factorable. I'll show you how, and then I'll come back over to this. So if I want to factor x squared plus 5x plus 6, I need to think about two numbers that will add to the 5 and multiply to 6. So in order to do that, I look at the factors of 6, the multiplication. The things that multiply to give me 6 are 6 times 1 and 2 times 3. Now which one of these will add to give me 5? Well, it's 2 and 3. So what we do is with those two numbers both being positive, we're going to put them in parentheses like this. X plus 3 and x plus 2. The order doesn't matter. 2 could go first, 3 could go first. Doesn't matter. So that's what that's equal to. If I multiply these two back together, I would get that right there. So this guy right here is going to get factored into x plus 3, x plus 2. I'm going to bring down the 3x plus 3. So I'm going to brighten this a little. Now this is fully factored. And this right here, fully factored. But I don't just want it to be factored, I want the roots. Roots means we have to set it equal to 0. Then solve for x. So we're going to take this question, this fully factored polynomial here. I'm going to make a copy of it, and then I'm going to paste it so I have another one to work with. And this is going to be equal to 0. In order for us to figure out what this is, or rather, I guess I should just move that out of the way. In order to solve for x, so we have it set equal to 0. Now we just have to solve for x. In order to solve for x, we say to ourselves, well, what if each one of these bubbles was equal to 0? Well, I'll start with the easy ones. What if x plus 3 was equal to 0? Well, then x would be equal to, let's get it by itself. X would be equal to negative 3. Now I should box that because it's actually one of my solutions. If x plus 2 was equal to 0, then I would do minus 2 to cancel that out, and x would be equal to negative 2. That's my second root. On the left-hand side, I say, what if 3x plus 3 was equal to 0? Well, I got to get x by itself, so minus 3 minus 3. I get 3x is equal to negative 3. Divide by 3 on both sides to get rid of this 3. And now x is equal to negative 1. These are the three roots of the equation. Now what the roots mean is it means where the function crosses the x-axis. So I'm going to take those three roots, negative 1, negative 2, and negative 3. I'm going to go to my graph. This is for question number 8. I know that my function crosses at negative 1, negative 2, and negative 3. It doesn't really matter how you draw this, at least not for now, but we want to make sure that the function goes through all of these points. So it's going to be some sort of a squiggly function, looks like that, or it might be flipped around the other way. It might be down over here, and then like that. But we want it to cross through all those points. That's the whole idea of a root or an x-intercept, is that it's these points right here. We're trying to find where the function is equal to 0. So that's how you graph it. Now let's look at number 9. I recommend right now that you write number 9 down and try number 9 yourself before you go watching the video. You just watched an example. You can always go back and rewatch it, but I want you to try number 9 before you watch this part. Okay, so just pause it now, work on number 9, and see if you can finish it yourself, and then watch the rest of this for a check. Okay, if you are watching, I assume that you've done this already, in which case this is a check. This is not a full explanation. I already did the full explanation on the previous example. Negative 2x goes into negative 2x cubed x squared times. Multiply down gets me negative 2x cubed times negative 4 gets me negative 4x squared. Parentheses and subtract. I love these because two terms cancel out. That means I save a step. I get to bring both of these down. And ask myself, how many times does negative 2x go into 2x? It goes in negative 1 times. Negative 1 times negative 2 is 2x. Negative 1 times negative 4 is positive 4. Parentheses and subtract. These both cross out, and I get a 0 remainder. That's awesome. So now I'm going to take the divisor and the quotient, and I'm going to put them up next to each other. Negative 2x minus 4 and x squared minus 1. If you don't know what to do with this guy right here, We just learned it today in lesson number 7. We did it a little bit in lesson 6. This is dots, or the difference of two squares. What this factors to is going to be x plus 1, x minus 1. If you want to try to do the add and multiply method, right, the whole double bubble adds to this, multiplies to this method that we did on the previous question, you would have to take this over to the side and add in a 0x in the middle, x squared plus 0x, because that term was missing, minus 1. And now you can look for the two numbers that will add to 0 and multiply to negative 1. They happen to be these two numbers, plus 1 and minus 1. So that's what that factors into. I'll bring down the negative 2x minus 4, set this all equal to 0. I'm going to t-chart it. On the right-hand side, x minus 1 equals 0, plus 1 plus 1, and I get that x is equal to 1. In the middle, I'm going to get that x is equal to negative 1. That's two solutions already. Those are easy. The easy way to do it is to say x plus 1 is 0, so it must be minus 1, because negative 1 plus 1 would equal 0. On the left-hand side, I'm going to get negative 2x minus 4 equals 0, plus 4 on both sides first. I get negative 2x is equal to 4, divide by negative 2 on both sides, and you get x is equal to 4 divided by 2 is 2, but it's positive divided by a negative, so it's going to be negative 2. Now the graph for this one has three roots, negative 2, negative 1, and 1. Negative 2, negative 1, and positive 1. Once again, it doesn't really matter which way you draw this. It could be up over here, but it should come down through these points, and I keep messing it up. That's vaguely right. It could be that, or it could be down like this, up through here, down through here, and then it must continue up off the graph like that. It could be either one. It depends really on the sign of the function, but we don't have to worry about that for this lesson. The only thing that really matters are these points. If they're graphed correctly, that is full credit. Okay? Good luck with this weekend's homework.